And these videos, in this particular video, we're going to go over some of the proportion problems that you'll see in the study guide. So the first one here, time and temperature recorded as follows. So here's my time, here's my temperature, 3, 6, 9, 12. Goes up. Here's my temperature recorded after so many minutes. Is there a proportional relationship between time and temperature? If there, yes, what is the common ratio? So remember, to find the common ratio, I simply need to set up a ratio between my two things I'm measuring. And time is almost always the x, and so I'm going to make that the x-axis, the x variable, and y is going to be my temperature. So what I want to do is I just simply want to consider what is y over x. What's the y value over the x value? So 18 divided by 3, so 18 over 3, that's 6. 36 over 6, that's 6. 54 divided by 9, that's 6. 72 divided by 12, that's 6. So yes, it is proportional. And the common ratio this time is 6. The weights of 4 different types of wood, oh, that's a typo right there. Oh, that should have been a U. I can say the weights of different types of wood were taken for 3 lengths, 3 feet, 6 feet, 9 feet. So here's these different types of wood. Here's each wood is cut different lengths, and here are the weights. Which of the materials above does not have a proportional relationship? So I can test this by doing the same thing I did in 18 by checking if there's a common ratio at each point. Because once there's the common ratio does not appear, you know that's not proportional. So if I looked here, 9 divided by 3 is 3, 18 divided by 6 is 3, 27 divided by 9 is 3. For wood, so this is proportional, so that's okay. Wood 2, 18 divided by 3 is 6, 36 divided by 6 is 6, 60 divided by 9 is not 6. So, because it's not 6, this is not proportional. So wood 2 is not proportional. And if we check the others, 21 divided by 3 is 7, 42 divided by 6 is 7, 63 divided by 9 is 7. So that works out. So wood 2 is definitely not proportional. Which value would complete the table to make a proportional relationship between the variables x and y? So I see I've got this table, and I need one value here to check to make this to see that this whole table is proportional. Well, I notice here I'm going up by 2.5. And even here, so each step I'm going up by 2.5. So if I just find out how much it's going up here between any two I do know, I can simply add it to 25. So what is 18 and 75 hundredths minus 12 and 5 tenths, or 50 hundredths? So 5 minus 0 is 5. 7 minus 5 is 2. 8 minus 2 is 6. So every time it's going up. It's going up by 6 and 25 hundredths. So if I take this and I add it to 25, so 25 plus 6 and 25 hundredths. 25 hundredths comes down, just adding 0. 5 plus 6 is 11, carry the 1. There's my value for y, 31 and 25 hundredths. Because if I add 2.5 to this, 5 plus 0 is 5, 2 plus 5 is 7, 1 plus 2 is 3, and 3. And look, I get the same value. Oh, 6. Oh, I added the wrong thing, excuse me. 625. Sorry, that's all wrong. So if I go 3, 3125, and I add my difference here, 625. Okay, so now I'm adding the right thing. 5 plus 5 is 10, carry the 1. 1 plus 2 is 3, plus 2 is 5. 1 plus 6 is 7. Bring the 3 down, and lo and behold, I get the same value here, 37 and 5 tenths. The data set below shows a direct variation, so they're telling me already it's proportional. What is the constant of proportionality for the relationship? Recall that the equation for direct variation looks like this. Y equals AX, where A is the constant proportionality. So if I divided both sides by X, I see that A is simply the Y value over the X value. So let's choose an easy Y value and an easy X value to consider. Let's choose that. So Y over X would mean 15 over 10, and that simplifies to 3 over 2, or you can say that, or 1.5. So I have an equation here. This direct variation equation looks like this. Y equals 1 and 5/10 X. So for every value X, if I multiply it by 1.5, 1 and 5/10, I'll get this value. So if I plugged in 8, let's try it. 8 times 1 is 8. 8 times a half is 4. 8 plus 4, 12. 22 here, the temperature of the air was constant as the day began, then rose sharply and remained steady for a while before the temperature dropped. So it started out steady. So if it started out steady, it can't be this, because this is starting out growing. So there's, so we can start those right there. So far so good there. It starts out steady as the day began, then rose sharply. So it started, let me get it. So the temperature was constant, not changing as the day began. Then rose sharply. So it's rising sharply, that's good. And remain steady for a while. Well, here, this thing's changing again. That's remaining steady before it dropped. So correct answer, B. Oh, so it rose sharply and then remained steady for a while. The order of pairs 3.5, 210, 4.5, 270, and 7, 420 are plotted on a graph showing the distance traveled by a motorcycle for a specific amount of time. What ordered pair would indicate the unit rate? Remember, unit rate is 1. So here we've got a specific amount of time, right? It's telling me, and a certain distance traveled. Well, distance divided by time is a very common way to travel. And so that would suggest that maybe we can think of this as the time traveled in 3.5 hours. This is indicating they traveled 210 miles. So, and that makes sense because the rate is how fast I go, and I travel in miles per hour. So the unit rate is how far did I travel, how many miles, in 1 hour. I can use any one of these 3 points. So if I went 420 miles in 7 hours, I'd simply divide this, and I would have it. So 420 divided 7, well, that's just 42 divided by 7, which is 6, and you tack on the 0. So 60 miles in 1 hour is the unit rate in this case. And that should make sense, because if I travel 60 miles an hour for 7 hours, I'd go 420 miles. Hope this helps.